All right, let's try some operations with scientific notation. So first of all, let's try multiplying or multiplication with numbers in scientific notation. When multiplying numbers in scientific notation, we'll multiply the base numbers together. Then we'll add the exponents together. If the number is not in between 1 and 9.9 repeating, we need to rewrite it in scientific notation, and that means that we're going to add 1 to the exponent. And I'll show you why here in a second. So here's one example, mostly already done. So the original problem is right here. We're taking 1.4, oops, that's not a highlighter. We're taking 1.4 times 10 to the 4th, that's funny, and multiplying that by 7.6 times 10 to the 3rd. So this is really all multiplication. This is multiplication, this is multiplication, this is multiplication. So let's rewrite these base numbers right here together, and let's multiply that. When you multiply it, you get 10.64. Now here, we took the times 10 to the 4th and times 10 to the 3rd, and we rewrote those. So really all four things here just got re-scrambled, and with multiplication we can re-scramble things because multiplication is commutative. So now we have the same bases, 10 and 10, raised to the exponent of 4 and 3. So we can use the property where we just add the exponents together when we have the same bases, power of a product. So we get times 10 to the 7. However, this number out in front is supposed to be between 1 or equal to 1 or greater than 1 and less than 10. Well, it's a little more than 10. We're just supposed to have one number to the left of the decimal point. So I need to move it to the left 1. Now when I'm doing that, I'm saying, oh, this number is actually bigger than we wanted it to be. So that means I need to add 1 to that exponent. So the answer is going to be 1.064 times 10 to the 8th power. Times 10 to the 8th power. Let's try some of that. So we're going to take the numbers out in front and multiply them together. We get 12 times 10 to the, add these exponents together, we get times 10 to the 4. But I need this number to be between 1 and 10, 1 included. So the decimal point needs to actually be right there. So I moved it from there to there, which means I need to add 1 to the exponent. So the best answer, the answer is, in scientific notation, 1.2 times 10 to the 5th. Now this adding 1, this having to move the decimal point, is not going to always happen. Let's try the second example. When you take 1.2 times 2.3, so multiplying these numbers out in front together, you get 2.76. Hey, that's okay. That's the way we want our decimal to look in scientific notation. Times 10 to the, what power? Take negative 6 and add it with 4. So we get negative 2. Bada bing, bada boom. When we divide values, we're going to actually divide the base numbers. Then we're going to subtract the exponents. This is like our old battle, right? We're battling right here. We're dividing right there, or simplifying that fraction. If the number is not between 1, so I'm just going to say if C is not greater than or equal to 1 or less than, less than 10, then we need to rewrite it. Now if we have to rewrite it this time, it means the number is likely going to be too small to be in scientific notation. So we're going to have to subtract. We're going to have to move it to the right and subtract 1. From the exponent. So here we're going to divide these values, and we divide them, you get 0.25. You can actually go straight to your calculator on that. Then we subtract right here. So negative 1 minus negative 4. I just subtracted the exponents. It has to be top minus bottom. That gets us 3. So we have an issue here that our number out in front is not where it should be. I need to take this decimal point and move it 1 to the right. Meaning that this answer is a little bit too small for what it needs to be in scientific notation. I need to subtract 1 from that exponent. So 2.5 times 10 to the 2. Let's try that out here. So when we divide these numbers, we get 6 times 10 to the -1 minus -1 is 0. And this number is between the values that it should be, so we're good. Let's divide here. We get 2.67 times 10 to the power of, take -3 minus -5, you get 2. So that's our new exponent. And this number is an appropriate number to have out in front, so we don't have to do any modifying there. Last idea. What if we take the power of a scientific notation? So when we take a power to a number in scientific notation, we compute the power of the base. We'll sprinkle that in. Then, when we take a power to a power, we multiply the exponents. And again, our number out in front needs to be greater than or equal to 1 and less than 10. Then we'll have to think about how did I have to move that exponent, and you'll have to apply a variation of what we've been learning about how we rewrite numbers in scientific notation. So let's give this a shot. We're going to sprinkle the exponent there and take 4 to the 3rd. And then when I sprinkle it here, I have to add the exponents. So I get 10 to the -6, -2 times 3. 4 to the 3rd power is 64. Now, this number in front needs to be 6.4. It's actually too big. So I need to add 1 to the exponent. So it's going to be times 10. -6 plus 1 is -5. 6.4 times 10 to the -5. Let's try that here. And boom, boom. Take 3 to the 2nd power. So we get 9. And then we multiply the exponents. So times 10 to the -6. Bada bing, bada boom. Let's try it here. Take 9 to the 2nd power. We get 81 times 10 to the, multiply the exponents together, we get 6. Well, the decimal's right there right now, but I need it to be right here. So I want it to say 8.1. Now this number's too big, so I need to add 1 to the exponent. So I get 8.1 times 10 to the 7.